All right, on the vector diagram in your answer book, use a ruler and a protractor to construct the following vectors. I'm going to start at the arrowhead of the second displacement vector, so I'm going to start right here, and I'm going to draw a vector to represent the 0.3 kilometers east displacement. All right, so I know 1 centimeter is 0.2 kilometers, so 0.3 kilometers is going to be 1.5 centimeters. All right, so I'm going to take my ruler here. I'm going to place it right there at the tip of that arrow, and I'm going to draw a vector that's 1.5 centimeters long. Okay, I'm doing this on a smartboard, so it might not be perfectly accurate, but on your paper, do it with a ruler, make sure it's 1.5 centimeters and a straight line. And it also says to label the vector with its magnitude, all right? So make sure you label it as 0.3 kilometers. All right, then for the next one, draw the vector representing the resultant displacement of the girl for the entire bicycle trip and label the vector R. All right, so for this one, for the resultant displacement, I'm going to start, resultant displacement is going to go from start to finish in a straight line. So it's starting at point P, and it's going to end at the tip of that last vector I just put, okay? Do this with a ruler to make sure it's a nice straight line. All right, and the direction of the resultant is from start to finish. All right, now let's move on to number 72. All right, for number 72 to 73, calculate the girl's average speed for the entire bicycle trip. Now remember, speed is going to be total distance over time. So the distance of the whole path, that's 1.4 kilometers plus 0.7 kilometers plus 0.3 kilometers. So I have 1.4 plus 0.7 plus 0.3. The distance is going to be 2.4 kilometers or 2,400 meters. All right, the time is 12 minutes. The time is 12 minutes, so that's 12 times 60 to get that into seconds, 720 seconds. All right, so then it's very simple. Speed is distance over time, 2,400 meters over 720 seconds is 3.3 meters per second. All right, determine the magnitude of the girl's resultant displacement for the entire bicycle trip. There's two ways you could do this problem. One, you could take your ruler, you could measure the distance from start to finish, and then convert it from centimeters into kilometers using the scale. All right, you can do that, or you can do it with the Pythagorean theorem, which is what I'm going to show you. So first we have to split this up into a triangle because we have a trapezoid here, and we can't do Pythagorean theorem on that. But we can just make this into a triangle. All right, this triangle here. All right, I know this top side here is going to be, this is all 1.4 kilometers, and this distance is 0.3 from here to here. So this distance on this side is 1.1 kilometers. All right, the other side, 0.7 kilometers. So I do the Pythagorean theorem. A squared plus b squared equals c squared. So I have 1.1 kilometers squared plus 0.7 kilometers squared equals c squared. And I get c equals, so I get c equals 1.3 kilometers or 1,300 meters. All right, finally, we're going to determine to measure the angle in degrees between the resultant and the 1.4 kilometer displacement vector. So that would be this angle right here. All right, I want to know this angle. Okay, so one way you could do this, you could take a protractor. Be very careful to measure the angle. That's a perfectly legitimate way of doing it. Or we can do it with a little bit of trigonometry. All right, I see here that I have the opposite side, 0.7 kilometers, and the adjacent side, 1.1 kilometers. So opposite and adjacent, I would use tangent. So tangent of theta is opposite over adjacent, 0.7 kilometers over 1.1 kilometers. All right, so to put that in the calculator, we do inverse tangent of 0.7 over 1.1. All right, and make sure your calculator is set into degree mode, and we should get theta equals 32.5 degrees. Okay, and that's 75.